Let me give you an example. I think intuition is a great way to start off talking about things, but after a while, it can get too abstract. So let's say you've got a signal and it's equal to this. So you can kind of see what it looks like. It looks a little bit like your grade distribution. It starts off at 3, and then the next one would be at 3/2, and the next one would be 3/4, and 3/16, and so on. 3/8, 3/16. There we go. And all zeros out here. So this is your input, and the question is to find the DTFT. So x of j omega, by definition, is equal to the sum over all time of your signal times e to the minus j omega n. So for this particular waveform, it's equal to 3 to the 1/2 n e to the minus j omega n. Now, as a quick aside, and this is something that you'll need to be able to derive on your own. You probably have not worked too much with summations. The rules are just like for integrals. In fact, summations are the discrete time version of an integral. If you're summing over n of a constant times a function of an n, you can move that constant right outside that summation sign, just as if it was an integral. And also, just like an integral, if you are summing of a function of f of n plus g of n, just like an integral, you can pull it out into two separate summations, just like you could pull it out into two separate integrals. So we can pull that 3 out, and we'll get the sum from n equals minus infinity to positive infinity of 1/2 e to the minus j omega, and all that times n. So I noticed that this was 1/2 to the n. I noticed that this is e to the minus j omega to the n, and so I just combined them here into one complete waveform. Maybe I should have made that more clear. Just as another reminder, if you have a to the n times b to the n, that's the same thing as combining ab to the n. That's what I just did. The related algebraic identity is a to the b times a to the c is equal to a to the b plus c. So we're up to here, and now we need to figure out this. Another aside, I want to derive what this is equal to, and you will need to know how to do this derivation, so look at it carefully. Essentially, what you're doing here is you want to know what the summation is from n equals 0 to infinity. Oh, shoot. So since we've got one thing I did not make clear, there is a u of n here, and so we needed to change the summation to start from 0, because although here we're summing for all negative values of n, when you multiply a negative value of n, when you put that into our u of n, it's multiplying this whole thing by 0. And so it's the same as removing the u of n and starting to sum from 0. So let me make that change over here too. So we want to find what this thing is equal to. And I think it's even easier if we replace this nastiness inside the parentheses with just one number. Let's say it's equal to a to the n. I'm going to evaluate the first several terms of that. That's a to the 0 plus a to the 1 plus a to the 2 plus a to the 3, and so on forever. Now a to the 0, we already know what that is, right? That's a simpler way to write that. It's just simply 1. Be able to do this. You can see that the relationship with every single number is we're just multiplying it by a. I'm going to multiply our y by a. And if I multiply this whole thing by a, then 1 times a is a, and a times a is a squared, and a squared times a is a cubed. And now on the left, I'm going to subtract this bottom from the top. So I'm going to say y minus ay. I'm going to subtract these top two things. And that equals this top part minus the bottom part. But when I subtract that, the only part that gets left over is my 1. And so now I can use the distributive property to group this on the left. That has to equal 1. And so therefore, my y, my answer to this whole thing, is just this isolated. So I'm just going to divide both sides by 1 minus a. And that is what this thing is equal to. Be able to do that on your own, that derivation. And then you can, once you understand how to do this, you can do all kinds of tricks with this. You can start the summation from 1 or 3 or anything else. Armed with this, we can now directly find out what our DTFT is. It's going to be 3, and then this thing from over here is equal to 1 over 1 minus 1/2 e to the minus j omega. And that's it. That's our DTFT.